When looking up at the night sky, it's easy to wonder what's out there, in the enormous universe that we are but a tiny part of. It's no secret that we are unbelievably small, incomprehensibly small, evidenced by the fact that there are so many supermassive things we do not yet know the full sizes of, including our own universe. But does size actually end? Well, theoretically it should, but new discoveries made every day challenge that theory. Size is something that doesn't seem to listen to the rules. From physical bodies to structures to galaxies to clusters, gravity is the amazing thing that seems to be binding these things into larger and larger phenomena. The question is, what is the biggest thing we've ever discovered, and how big is it? Well, that's what we'll be looking at today as we journey up the ever-increasing ladder of size to determine the biggest things in the universe. Obviously, when thinking size, the go-to one is planets, but we'll get to that. First off, we have to look at the subclassification, a dwarf planet. There was a lot of controversy when Pluto was declassified as a planet by scientists and instead was put to dwarf planetary status, mainly because dwarf planet may as well just be a fancy name for very large asteroid in some respects. With a diameter of just over 2,000 kilometers, Pluto is the largest dwarf planet we've ever discovered. But what's the largest large asteroid? Well, there are probably many millions of larger ones out there, but the largest we've ever discovered is Ceres, a neighbour to us within our own solar system and the nearest minor planet to the Sun. Discovered in 1801, Ceres is the 33rd largest body within the solar system, and is the largest minor planet. For those of you who don't know, minor planet is kind of the next classification down after dwarf planet. It just essentially means large asteroid. Its diameter is about 950 kilometers. To put that in some kind of perspective, the United Kingdom has a total top to bottom length of about 1,400 kilometers. So Ceres could theoretically be placed on countries like the US, Russia and some landlocked countries in Africa with ease. And this is the largest minor planet. Suddenly it gets a little easier to understand why not all celestial bodies are considered as planets as such. I'm going to skip over moons as a subcategory here. Long story short, Ganymede of Jupiter is the largest moon we've ever discovered, and it's twice the size of Pluto. That, along with many other moons we've discovered, are all larger than Pluto. Ganymede itself is about 2 times as large. These are all quite small, but Ceres has some amazing possibilities for new life discoveries in the solar system. But that's for another video. Okay, enough about dwarf planets and moons. Let's talk about the real deal. Now, planets come in all sorts of shapes, sizes and makeups, with 2 to 3 trillion planets estimated in our galaxy alone. Accounting for all the planets would be a near impossible task. However, we do know that once a planet exceeds a certain theoretical size, it becomes a star, so we have this to work with when making our calculations. It takes about 80 times as much mass as Jupiter, the largest planet in our solar system, to begin the star-like process with hydrogen burning. Obviously, you won't find any planets 80 times larger than Jupiter, as atoms inside large planets begin to compress at a certain level, making more massive planets not scale in size proportionally. With scientific factors considered, we believe that the theoretical size limit of a planet is around twice or 3 times as big as Jupiter. Enter GQ Lupi b. Discovered in 2005, it orbits the star GQ Lupi in the constellation of Lupus, around 500 light years away. Given these planets are so small next to their stars and so far away, we use infrared techniques to identify them, and it's not 100% confirmed that this isn't a brown dwarf or failed star as some call them. But it could well just fall behind the line that splits the largest gas giants from fusion-capable failed stars. It is about 2.5 times bigger than Jupiter, but could be several times more massive. We don't really know. It's a bit of a guessing game. But that's just the beginning. Planets are underwhelming when it comes to size. In a big, enormous leap, we are moving from planets to stars, the other side of the cut-off point between gas giant and brown dwarf. Even GQ Lupi b is dwarfed next to our own Sun, but our Sun is dwarfed next to much larger red giants and supergiants. The largest stars could be covered in their own video, but if we head up to the very top of the range, we have UY Scuti, an absolute beast. UY Scuti is a red supergiant in the constellation of Scutum, about 5,000 light years away from Earth. It was first catalogued in 1860, but it wasn't discovered to be the biggest star we know of until a few years ago. This thing is huge, like almost scarily huge. Looking at it straight on, you wouldn't even be able to see the Sun next to it. It almost numbs the mind as to how massive this thing is. But for an easy bit of WTF measuring, if you placed UY Scuti at the centre of our solar system, it would not only extend far enough out to swallow the Earth, but it would completely engulf everything all the way out to Saturn. At just under 3 billion kilometers in diameter, it's so enormous that if you were travelling around the surface at the speed of light, it would take you a full 7 hours to circle it once. Compare that to the fact that light could circle our planet 7 times in under a second. And it would take just 14.5 seconds to circle the sun. The numbers don't really do the size of this thing justice, but as with anything in space, it keeps going. We theorise that stars could realistically get bigger, and Uy-Scuti is merely in our own galaxy. Imagine what's out there in some of the bigger ones. But there's something bigger, as always, something that exceeds the size of a star and does it pretty frighteningly. Enter black holes. Black holes are a scary part of astrophysics, not least because of the extremely volatile and hostile manner at which they form, or the creepy imagery associated with them. In fact, one of the scariest things about black holes is the sheer size they can seemingly grow to. We know that supermassive engine black holes are the gravity wells binding most galaxies together, and these can reach scary big when thinking about size. But the biggest black hole we know of is in fact a theoretical one. Located near the galactic North Pole, TON 618 is the name given to a very distant and super bright and radio loud quasar. It was discovered in 1957, but a radio survey in Bologna has since indicated that a faint, vibrant glow was a quasar. The thing is, the light being emitted from this quasar is incredibly bright, but is also estimated to be almost 10.5 billion years old. This thing is shining from deep within the visible universe. This thing shines with an absolute visual magnitude of minus 30.7, as brightly as 140 trillion suns. This makes it one of the brightest objects in the universe that we know of. It is thought that TON 618 is the accretion disk of extremely hot gases swirling around an engine black hole in the centre of a galaxy. We can't even see this galaxy because the quasar outshines it. But to shine so brightly from so far away, gravity suggests that the culprit black hole behind the quasar may weigh up to 66 billion solar masses, so that's 66 billion times heavier than the Sun. This is so massive that it is no longer classifiable as a supermassive black hole, instead being named an ultramassive one. With a few more calculations thereafter, we can determine that the Schwarzschild radius of this projected black hole is a massive 1,300 astronomical units, so 1,300 times the distance between Earth and the Sun, all just a massive expanse of black, all-consuming solar abyss. Black holes can be scary, but size-wise, they pale in comparison to the next level up in size, a nebula. A nebula is a giant cloud of various dust and gases in space, emitted by the supernova of a dying star. Quite spookily, they are almost like the ghosts of stars that once were, taking on some absolutely marvellous formations. But they can also be gigantic. The average size for interstellar nebulae ranges between 1 astronomical unit and 10, but some can get much larger. This is where we go above the boundary of a light year in diameter. Some nebulae cover multiple, sometimes even dozens of light years. Going up to the very largest nebula, we have the Tarantula Nebula, aka 30 Doradus, aka NGC 2070, based on its star cluster. It is located within the Large Magellanic Cloud, a small dwarf galaxy at the edge of our Milky Way. It is the most active starburst region of the local group of galaxies and covers about 1,800 light years. This isn't just bigger than the largest black hole ever discovered, it's billions of times bigger. It's so big that if it were in the Milky Way, in the same position as the Orion Nebula, it would cast literal shadows on Earth. A scary thought to be sure, but it would make for some pretty cool nighttime viewing. From dwarf galaxies to supermassive ones. Now, as with stars, the range in scales between the largest and smallest galaxies is mind-bending. It seems like we're jumping the gun a lot, undercutting the vast majority of incredible galaxies in favour of the largest known one, but this thing is truly remarkable. It is IC 1101, a supergiant elliptical galaxy approximately a billion light years from Earth. From telescope images, this thing absolutely outshines its neighbouring galaxies in its cluster. Elliptical galaxies are generally the largest kinds of galaxies as well as the oldest, and IC 1101 is no exception. Estimated to be over 6 million light years across, with potentially around 100 trillion stars contained within. This thing is not just a beast, it's the beast. If it were put at the centre of the local group with us, it would swallow up the Andromeda Galaxy, the Large Magellanic Cloud, and more. Like most of these other elliptical galaxies, IC 1101 owes its size to galactic collisions across billions of years, but it isn't actually creating any of its own new stars as it moves into the twilight stages of its life. Given that the size of engine black holes correlates directly to the size of a galaxy, IC 1101's central black hole was at one point in time thought to be the largest black hole in the known universe. However, our friend TON 618 has challenged this. But still, every component of this galaxy is nothing short of awesome. Even though it may start declining in star numbers, with 100 trillion stars within, you have to wonder what might be going on within that galaxy right now. From galaxies to galaxy clusters, size is still increasing on our list, but this is where it becomes a bit less objectified and we start to spread into more patterns of things and loose groupings. Probably the most spectacular of the lot would be galaxy clusters. These are the largest known gravitationally bound structures in the universe, with the exception of the recently discovered galaxy filament. We sit nice and cozily in the Laniakea supercluster, Laniakea meaning immeasurable heaven in Hawaiian, and I'm sorry if I'm pronouncing that wrong. That contains about 300 to 500 clusters of galaxies, making it home to approximately 100,000 galaxies. There are loads of other superclusters, but the largest is the Calum supercluster. Its existence is still theoretical by some nature, but it's estimated to span just shy of 1 billion light years across, containing approximately 500,000 galaxies. That's big, but with the aforementioned galaxy filament discovery, we must also consider the Pisces Cetus supercluster complex. This is the largest known galaxy filament, just heading off Calum and exceeding the billion light year dimension. Technically, the Laniakea supercluster is a member of the complex, so just remember, no matter how insignificant you feel, you are part of the biggest galactic structure in the known universe. So from a structure which is full to the brim of interstellar contents to one that has nothing, let's talk about supervoids. Now, supervoids are obviously something I've had great success with on the channel, but with that creepy stuff aside, voids are quite common in space. The universe is kind of like a sponge. There's lots of clustering, and then there are giant holes in the middle, disputed only by the theory of even distribution of matter after the Big Bang. However, there are some voids that are far too big for explanation, but this is where it gets slightly intangible. By definition, all a void is simply a less galaxy-dense area of space, so the expected numbers of galaxies dips in the region of a void. We stereotypically picture a void to be completely empty, devoid of all cosmic activity, but by the textbook definition, the largest known void in the universe is the KBC void, a 2 billion light-year expanse where the expected numbers of galaxies dip. But here's the thing, we are within the KBC void. The void contains our local group and much of the Laniakea supercluster. Right now, you are not only sitting in the biggest galaxy supercluster, but the biggest void in the known universe. Pretty underwhelming, right? Well, I think so too. So instead, I'm going to highlight a much more interesting void. It is the theoretical Eridanus supervoid. Now, there is no guarantee that this void exists. In fact, depending on your stance on parallel universes, you might even deny that this void exists. But at present, it's one of the best leads we have on the WMAP's CMB cold spot anomaly, an area of the cosmic microwave background radiation of the universe where the temperature drops pretty consistently by about 70 microkelvin, over an equivalent distance of anywhere between 500 million to 1.5 billion light years. The Eridanus supervoid, if real, shares a very creepy similarity with the likes of the Boötes void, in that it isn't just less galaxy dense, but it is comprised of hardly anything. I think there's a lot of scientific hype building videos around the KBC void just because we happen to be inside it, but voids like the Eridanus supervoid are much more interesting and out of place. The Boötes void, which is very real and has been confirmed, is 330 million light years across and contains 60 galaxies where 10,000 would be expected. At a lower bound guess, the Eridanus supervoid could be about 500 million light years in dimension, but the upper bound could be up to 1.5 billion. Thinking that there is an area that size of emptiness is truly frightening and kind of sad, really. Now we come to something very interesting, not a structure, but the theoretical limit at which cosmic structures can no longer exceed. This is due to the cosmological principle. In very, very basic terms, the cosmological principle states that, when viewed on a large enough scale, the properties of the universe are the same for all observers. In layman's terms, the universe is pretty consistent in form and structure over its entire expanse. Stars, galaxies, clusters, black holes, dark matter, etc. All reasonably well distributed and following the same patterns of occurrence. But combining this theory with things like the uniform distribution of matter theory and other things we believe to be a fact of cosmology, physical structures should not be able to exceed the size limit of about 1.2 billion light years. The Eridanus supervoid could be an anomaly, but then again we don't even know if that exists. So apart from that, that should be it, right? Well, in spite of all of this, size still increases. Enter the Sloan Great Wall. Sitting very smugly above the theoretical limit, the Sloan Great Wall, or SGW, is sort of like a galaxy filament, except it's kind of like the next level up. Galaxy filaments are quite a new concept, given we've only been able to observe such a vast amount of area for a short period of time. The Pisces Cetus complex we discussed earlier is almost a compound cluster, which is making up the filament, but this wall is more like a compound filament. The lines are pretty blurred while we still figure out where the line between supercluster, filament and wall is drawn, but regardless, the Sloan Great Wall is enormous. Measuring at 1.38 billion light years across and approximately 1 billion light years from Earth, the Sloan Great Wall covers 1/60th of the diameter of the observable universe. It contains several superclusters of galaxies and is currently the 6th largest known object in the observable universe. Scientists are still trying to piece together the nature of this thing. In 2011, it was propositioned that this monster is, in fact, just a coincidence, and that 3 other slightly smaller cosmic structures just happen to be aligning at the point in time we exist to observe it. Given the waiting time for cosmic movement in the universe is usually billions of years, we probably will never know whether this thing is a coincidence, but it's still absolutely enormous, and it challenges cosmology itself if authentic. But not to worry, as there's still plenty more to cover that is a lot less coincidental. There are supposedly 5 cosmic structures larger than the Sloan Great Wall known to science, and these are quasar groupings and gamma-ray bursts. This is where things stop being structures and start being networks of unique events. However, they are not to be ignored. Clowes-Campusano, U1.11 and the huge LQG are all quasar groups, all spanning in excess of 2 billion light years. However, if we go up to the very top, we have the giant gamma-ray burst ring. First discovered in 2015 through a radio survey of gamma-ray bursts, the giant GRB ring groups 9 bursts together in a formation spanning a whopping 5.6 billion light years across. Given only 9 cosmic events over 5 billion light years is quite sparse and reaching, many people don't consider the giant GRB ring a structure, but it is because of the ring-like nature of these bursts. It seems more like a structure than chance alignment of cosmic events, but you can quickly get yourself lost in sci-fi and fantastical theories over a seemingly random formation. Luckily, however, there's something a bit less reaching out there. And so this leads us on to the biggest question. What is the biggest thing in the known universe? Well, it's another gamma-ray burst formation, not a ring this time, but another wall. It is the magnificent Hercules Corona Borealis Great Wall. Discovered a year before the giant GRB ring, the Hercules Great Wall is the first so-called structure ever to exceed, wait for it, 10 billion light years across. Whereas the GRB ring was a stretch to believe that there is any design behind it, there is something off-puttingly significant about this superstructure. The wall occurs across the 2nd, 3rd and 4th northern galactic quadrants of the sky, and in this area the concentration of oddly similarly distanced gamma-ray bursts increases unusually. The entire wall consists of 19 bursts. A concentration of gamma-ray bursts this high is very unlikely, but was put to the test by a team of Hungarian scientists who used Kolmogorov-Smirnov tests to determine the probability of such a structure occurring out of chance. They divided 283 GRBs into sets of 31 and used 3 different methods of testing to determine the probability of natural existence, and the highest probability stated that there was only a 5.7% chance that such a structure could occur coincidentally. Other methods used suggested less than 1% chance of this happening. So why is this significant? Well, it's the fact that such a seemingly engineered distribution of bursts could be explained by a star formation in some kind of ultramassive megacluster, and such a cluster would also have to be in excess of 10 billion light years, making it the largest structure in the universe and then some. Chiefly, this thing is almost the stuff of science fiction, however it came into existence. And at 10 billion light years across, it is by default the biggest mystery in the universe. I might make a separate video on this giant soon. It's a very undiscussed mystery of astrophysics. Size never really seems to end. A 10 billion light year megastructure, even if it is the largest cosmological structure ever recorded, pales in comparison to the size of the universe. Due to a number of factors that make little to no sense, the diameter of the known observable universe exceeds that of its age. The observable universe is estimated to be about 93 billion light years across, dwarfing even the Hercules Corona Wall. But even then, size still doesn't end. There are theories that suggest that a universe outside of what we can observe, beyond the cosmic horizon, could be anywhere between 3 times to 250 times larger than the universe we have observed for centuries. Size is one of the only things you can be sure of in this life. It never ends, and we're always on the verge of discovering the next largest thing. Who knows what future surveys will uncover? Over the next few decades, we are sure to learn more about our universe, and perhaps something even bigger than the Hercules Corona Borealis Great Wall is lurking and waiting for us in the dark. So, from an asteroid smaller than the UK lurking within Neptune's orbit, to a planet twice as large as Saturn, to a black hole as large as our solar system, to galaxies, galaxy clusters, clusters of clusters, cluster filaments, great walls, right the way up to the universe itself. Size really is never ending. So, next time you take life too seriously, just think about the Hercules Corona Great Wall and think again. And with that, thank you so much for watching, and always remember to reach for the stars.